name is Gulshan Banu, working as an assistant professor, AI and DS department, SNS College of Engineering. So today I am here with a new topic called backtracking search, local search and the structure of CSPs. So now what is backtracking search? Backtracking search is something in which you will have a process which you will do in a repeated process, and it will be chosen as an unassigned variable and then tries all the values in the domain of that variable in turn, trying to find a solution. If an inconsistency is detected, then backtracking returns failure, causing the previous call to try another value. There is no need to supply backtracking search with a domain-specific initial state, action function, transaction model or goal test. That is, you don't have to do any kind of domain-specific things related to this backtracking. Whenever a process is being detected is incomplete, or if you think that the process has not attained the final solution, you have to do a backtracking search, right? So backtracking search keeps only a single representation of the state and alters the representation after, rather than creating a new one. Backtracking algorithm repeatedly chooses only the unassigned variables and then tries all the variables in a domain of that variable in turn, trying to find a solution. If an inconsistency is detected, then backtracking returns a failure, causing the previous call to try another variable. There is no need to supply backtracking search with the domain-specific initial state, action function, transaction model or goal test, as I have already mentioned. Now, this is the algorithm of how the backtracking search is being implemented. You will do a function and return a process if there is a failure occurring for applying each and every order domain values. If you have to do a process, you have to add different variables, and if you can remove the process if there is a failure occurring in the process. So in this map function, there are different countries that is related and the different coloring process that is related to it. In this process, when the process is in a failure state, you have to backtrack it and then do in an efficient way. Now, how we can improve the backtracking efficiency? By general purpose methods can give a huge gain in speed. Which variable should be assigned next? In what order should be it done, and how can we detect it? Now, in this most constrained variable and low constrained, least constrained variables are the two different types that is being dealt with this constrained variables. So most constrained variables, when you are having a longer number of constraints, it is called as more constrained. A good idea is to use it as a tiebreaker among most constrained variables. Now, what is this least constraining value? When you have a very least property of constraining values, it is called as a least constrained value, and this is the graph format of how the least constrained variable will be looking. Now, the forward checking is something which keeps track of remaining legal values for unassigned variable, and it terminates the search when any variable has no legal values. Now, what is this local search for CSP is all about? Okay, now local search is something that you are doing in a very predefined manner. Okay, local search algorithm for CSP uses a complete state formulation. The initial state assigns a value to each variable, and the search changes the value of one variable at a time. The minimum conflict heuristic is something which is dealt with this local search for CSP. In choosing a new value for the variable, select the value that results in the minimum number of conflicts with other variables. Now, there are different components that is being dealt with this local search for the constraint graph, that is vertices, edges, type of constraint, directed versus undirected form, and labeling. There are different applications that is being dealt with this local search, that is constraint satisfaction problem and the graph coloring. The analysis is the connectedness and the cycle detection. Connectedness is something which is dealt like how you are connected with the process, and cycle detection is the constraint graph can indicate dependencies that may complicate the solution process. So this is all about the process called backtracking, forward tracking search, and the local search, and the structures of CSP is all about. And this is the whole process of how the complete thing is being detected and how you can search the different kinds of process. So I hope that you understood the different types of backtracking, local search and structures of CSP. In the next video I will meet you with some other different topic, and from this the third units get ended up, and in the next video we will see like the different concepts of unit 4 and the process that is being involved in it. As of now, thank you.